Welcome to today's lesson on mixed numbers and improper fractions. Today's goals are students will be able to convert mixed numbers to improper fractions and back again. So let's get started. All right. First of all, we will go over this vocabulary in class, but I'll just go through it really quick. This is my writing from last year. Simplest form is when your numerator and denominator no longer have any common factors. So for example, if I have 4/8, I can divide those both by 4 and end up with 1/2. This would be called simplest form. A mixed number is a fraction that has a whole number and a fraction. So it has two pieces to it. 1/4, 11/3 would not be mixed numbers. The equivalent fractions are two fractions that are equal or cover the same amount. For example, you can see that 1/2 is the same as 2/4, which we covered earlier. A proper fraction is where the numerator is less than the denominator. So this looks right. It's not going to fall over. I always think of a pyramid. If the smaller number is on top, you have a nice pyramid, and these two can hold this one up. But if, like in an improper fraction, the top number is larger, reminds me of a pyramid that might look like this, where it's all going to topple over. So this is a proper fraction. An improper fraction then is when the top number, the numerator, is larger than the bottom, the denominator. All right, so let's take a look at this in action. So an improper fraction is a fraction in which the numerator is greater than or equal to the denominator. This model shows that. So we're going to take a look at 7/4. So we have two bars. It's going to be greater than 1, we know, because 4/4 would be equal to 1, which you can see right here. So because there's 7/4, we know that our answer is going to be greater than 1. So we're going to go ahead and draw two candy bars, split them into fourths, and then we'll color 7 of them. So you can see we have 4 here and then 3 left over here. So if we want to change that to a mixed number wants to know how many whole candy bars do I have and then what's left over. Well, you can see that 4/4 makes one whole candy bar, and then we have 3 more fourths over here. So our mixed number is 1 3/4, or 1 plus the 3/4 over here. Now down here, for each improper fraction, complete the model and write an improper fraction as a mixed number. So we're going to talk about 5/3. So we have two candy bars, and on the top row we cut them into thirds. So we're going to go ahead and shade 5 of them. Remember, the bottom number tells you how many pieces we're cutting the whole into, and the top tells us how many we have. So there's 1, 2, 3, 4, and 5. So by looking at our model, let's see how many holes we have. We have 1 hole, and then we have 2 pieces extra, and that's 2 out of 3. So 1 2/3. Now remember, this could also be thought of as a division problem. 5 divided by 3. Now if we do that, 3 goes into 5 one whole time, and then you can see that our remainder is 2. So we have 1 whole with 2 left over. Well, our denominator is never going to change. When we go from mixed numbers to improper fractions or the other way around, the number of pieces each whole is cut into remains the same. So if we have thirds here, we're going to have thirds here as well. So if 3 goes into 5 one time, that's my whole number. My remainder's 2. I had 2 left over, which is right here. That's my numerator. And then the denominator stays the same. Let's look at the next example. 7/6. So we cut each candy bar into 6 equal pieces, and we need 7 of them. 1, 2, 3, 4, 5, 6. And this picture, I'm sorry, is incorrect. The book did it wrong. So now this is cut into 6 pieces, but it really should look identical to this. So there's 7. All right, so what do we have? We have 1 whole candy bar, and then we have 1 extra piece. And remember, our denominator is going to stay the same. It's still cut into 6 pieces, whether I do improper or mixed. So 1 1/6. If we try our division method, remember it's 7 divided by 6. 6 goes into 7 one time with a remainder of 1. So 1 whole, Our remainder is 1 here, and the denominator stays the same. Let's try 6/4. So each candy bar is cut into 6/4, or into fourths. We want 6 of those pieces. We know it's going to be more than a whole because 6 is more than 4, and 4/4 would equal 1 whole. So 1, 2, 3, 4, 5, and 6. So let's see what we have. We have 1 whole, we have 2 pieces left over, and that's 2/4. Now notice this would be the same as 1 and 1/2. We can simplify that 2/4. Simply divide by 2, divide by 2, and our final answer would be 1 and 1/2. All right, let's move on to our notes. All right, so on your notes on the front page, would you please go ahead and make this T-chart, changing an improper fraction to a mixed number. If you just want to write improper fraction and then an arrow to mixed number, that would be just fine. All right, so we'll do this quick and easy here. Let's start with an improper fraction. How about 15/4? All right, so what I'm going to do is, some people can do this in their head and some people can't. What I'm thinking about is this. If I know that each whole, if it's cut into fourths, for every 4 pieces I will have 1 whole. So I want to know how many groups of 4 are in 15, because that will tell me my whole number. Well, I know that 4 goes into 15. Let's see, 4 times 3 is 12, so 3 times. Now, if I do 3 times 4, that's 12 of the 15 pieces. And so then how many do I have left over? I would have 3 more pieces to make 15. And then remember, our denominator stays the same. All right, let's try it. If you need help, if you're having trouble doing that in your head, let's do it with division. So this is 15 divided by 4. So let's go ahead and set that up. 15 divided by 4. So how many times does 4 go into 15? 3 times. So that means I can make, let's say we're talking about pies, 15 pieces of pie, and each one is a fourth. So I can make 3 whole pies, and then 3 times 4 is 12. This gives us how many leftover pieces we have. So you can see it's a remainder of 3. So there's 3 pieces left over, and then our denominator stays the same. If it's fourths, it's going to remain fourths. All right, so as far as explaining that, we're going to divide and find your whole number and your remainder. Okay, so again, your whole number is going to go here, and then our remainder is going to be our numerator. So this is the whole number of times that the denominator goes into the numerator. And then on the bottom here, we're just going to write a note that the denominator stays the same. Okay. All right, let's just try one more example, just for good measure here. How about, let's try 17/6. All right, so each pie is going to have 6 pieces. So I'm going to go ahead and see how many times 6 goes into 17. And 6 goes into 17, let's see, 6 times 2 is 12. So 2 times, that gives me 12 with 5 left over. So my remainder is 5. So my whole number is going to be, whoops, sorry, my whole number is going to be 2. 6 goes into 17 2 whole times. And then I have 5 pieces of pie left over. And remember, our denominator stays the same. All right, so that's just one more example. All right, so I'm going to model a game for you that you're going to play later on by yourself or with a partner. And how we're going to do this is, you're going to draw 2 cards and create an improper fraction. Now remember, because we want it to be improper, you're going to take whichever one's larger and have that be your numerator up on top. Then we're going to draw a model by using x's, make groups, and figure out our mixed number. So let's start by going ahead and drawing our cards. So we have a 6 and a 1. So my improper fraction is 6 over 1. My next step is to draw a model. Whatever our numerator is, that's how many x's we're going to write. So 1, 2, 3, 4, 5, and 6. All right, so we want to make groups of whatever our denominator is because that's going to make one whole. Well, this one's kind of an interesting one. Our denominator is 1. So what this means is you have 6 pieces of pie, and each piece is one whole pie. So really, we're just saying that we have 6 whole pies. Okay, so this actually isn't going to be a mixed number. It's going to end up being a whole number. Let me model a couple more for you. And if you want to just go ahead and watch right now, that would be fine. You'll do this later. All right, so we have 3 and 2. So let's put the larger number on top. Our improper fraction's 3 halves. The 3 tells us how many pieces of pie we have. So we're just going to make an X for each piece of pie. The bottom number tells us how many pies or pieces it takes to make one whole pie. So these pies are cut in half. So for every 2 X's, we have one whole pie. So we're going to circle our one whole pie that has our 2 X's in it, and then see what's left over. So you can see we have one whole pie with one piece left over, and remember our denominator stays the same. So 3 halves is equal to 1 and 1 half. Let's try one more. All right, I'm going to pick a different one here. How about 8/5? So our improper fraction is 8/5. This tells us how many pieces of pie. So let's make an X for each piece of pie. The bottom number tells us how many pieces makes one pie. So I'm going to put 5 pieces in a circle. 1, 2, 3, 4, 5. So here's a one whole pie, and then you can see we have some pieces left over. So one whole pie with 3 pieces of pie left over, and our denominator stays the same. So 8/5 is the same as 1 and 3/5. All right, so you'll try that later on. Again, you just need a couple decks of cards and the recording sheet that's in your packet. All right, so let's go the other way around now. We're going to change a mixed number to an improper fraction. So let's start with, how about 2 and 4/5? So again, you might need to pause, create your T-chart, and write down your example. All right, now this one has a nice little strategy as well. What we see here is we have 2 whole pieces, or 2 whole pies. Each pie is cut into fifths. So for every whole pie, I have 5 pieces. Since I have 2 whole pies, I have 5 plus 5, or 5 times 2. So our strategy is we're going to do the denominator times the whole number, and that gives us 10. Then the top tells us we have some leftover pieces. So we're going to go ahead now and add. So here we're multiplying. 5 times 2 is 10. Now we're going to take those 10 pieces that are in my 2 pies and add the leftovers. So 10 plus 4 equals 14. And then remember, the denominator stays the same. All right, so if we were going to explain this, it would be denominator times whole number, and then plus the numerator. That gives you the top of your improper fraction, and then remember the denominator stays the same. So that's a pretty simple way and short way to explain what's going on. Let's try one more example. All right, how about 4 and 3/9? All right, so we have 4 whole pies. Each one's cut into 9 pieces. So we're going to do 9 times 4 is 36. Then we're going to go this way and do 36 plus our 3 leftovers, So we have 39 pieces of pie. And then, of course, denominator stays the same. We can check our work by saying 9 goes into 39 4 whole times, and that's 36. We need 3 more to get to 39, so there's 3 left over. So you can always go back and check your work with both of these and see if your answers match up. All right, so this game is kind of backwards here. What we'll do is we'll draw 3 cards, and we'll just have the face cards all be worth 10. So the king will be our whole number, 10. Then our jack will be, actually now we have to take these two, put the smaller one on top. We don't want an improper fraction this time. So 10 will be our whole number, this will be 1, and then this jack will be 10. All right, so again, we're going to do 10 times 10. We're going to multiply that and get 100, and then 100 plus our numerator, and that gives us 101, and our denominator stays the same, so 101 tenths. Okay, let's try another one. All right, so we'll have our 3 be our whole number, and then we'll take the 5 sevenths. All right, and denominator times whole number, 7 times 3 is 21, and then 21 plus 5 gives us 26 pieces of pie. Our denominator stays the same, so 26 sevenths. Let's do one more. This time, why don't you pause the video after I give you the problem and see what you come up with. All right, so our jack will be 10, and then we'll do 2/8. So go ahead and pause, and then unpause to see if you are correct. All right, so 8 times 10 is equal to 80, and then 80 plus 2, we have 82 pieces of pie, and then our denominator stays the same. All right, so you can go ahead and keep working on this in your packet. We will also play a bingo game in class later on to practice mixed numbers and improper fractions. So good luck with this, and I will attach some short review videos in case you need them. Good luck.